All right, so for doing these types of problems, this is stuff that we've seen already this year in some various contexts, often much harder than this as well. Basically, we're just using distributive property because when we see expand, it's basically saying get rid of the parentheses. So I'm going to take this 5 on this first problem, and I'm going to multiply it into all 3 of those terms according to distributive property there. So that's going to give me 5x to the 6th, and then minus 15x, and then plus 40. There's our expanded form. That's all you need to do to it. There's nothing else you can do to it. Next one down. Again, I'm going to multiply the 6 to everything in this case. So the 6 times 3 gives me 18, so that's 18x to the 7th. Plus 6 times 5 is 30, so that's 30x squared. Then minus 6 times the 10, so that's going to be minus 60. Now, we start off with these because these are actually leading us into what we're doing today, which is going to be to do the same stuff, to do all this expanding type of work backwards. Today we're going to be focused on factoring. And so, really, when I say factor, it's the same idea of expanding except backwards. So, to factor is to introduce parentheses into it. All right, so when doing factoring, we're doing the same thing we just did, but backwards. So what we just did is I multiplied something in. So if I'm going to go backwards through that process, I need to divide. So that means I start by saying, what can I divide all 3 of those by? By 5, exactly. So that means that I'm going to pull the 5 outside of the parentheses like that. And then the stuff that's inside the parentheses is going to be whatever I get when I divide all 3 terms by that 5. And so 5x cubed divided by 5. Notice the number's gone, so I'm just left with x cubed. Technically, you might be thinking 5 divided by 5 is 1. And so it would be 1x cubed, but of course 1x cubed is the same as just x cubed, so we write it simply. Minus 15 divided by 5 is 3, so that's 3x. Plus 35 divided by 5 is 7. There's our factored form. That is now factored. Okay, we're going to do the same thing with the second problem there. Again, I look at all 3 terms, and what can I divide all 3 of those by? 3, yes, exactly. And so if I divide all 3 of those by 3, that means I got to pull the 3 outside of the parentheses. Because when I talk about these different forms, they still have to equal the same thing. We're just writing it in a different way. And so when we do that division by 3 here, 18x to the 5th, 18 divided by 3 is 6. So that ends up giving me 6x to the 5th. Plus, and then I do the 15x divided by 3 as well. Because I have to divide all of them by the same thing. So 15 divided by 3 is 5. So that's 5x. Then minus, and 24 divided by 3 is 8. And so you notice everything inside got divided by that 3. All right, so now we're expanding again. So that means I'm getting rid of the parentheses again. But in this case, notice I'm multiplying in the x's. So then as I multiply x squared by 7x to the 5th, you notice that the 7 that's out front, it doesn't change. Because I'm not multiplying by a number. But I am multiplying x squared by x to the 5th. And remember that when I multiply the x's, I add the exponents. Yes, because I have 2 x's, and then I have 5 x's that get multiplied with it, for a grand total of 7 x's that get multiplied. So that ends up being 7x to the 7th. Now, I need to multiply the x squared by the x. Notice there's no number out front, so it's just going to be x to the power of what? 3 is correct, yes, because remember that x is x to the 1, so I do the 2 plus the 1 when I add the exponents. And then minus, when I do 4 times x squared, there's no number in the x squared that changes the 4, and there's no x in the 4 that changes the x squared, so it's just going to be minus 4x squared. All right, same idea for the last one. So I multiply x to the 5th, and that's going to give me 8x to the 9th. Remember, add the exponents. Minus 5x to the 8th minus 2x to the 5th. And now those are expanded. We distributed in for both of those. And having done those, we can then use the same principles that we use for those in order to factor these. So again, write down those problems so that we then can work them through. So for that first one, we again need to factor it, which means introducing the parentheses. So I have to divide by something. The question is, what can I divide every term by? Well, you'll notice there's not a number that I can divide out of every term. Because some of you might be saying, well, what about 5? There's not a 5 in that first term, is there? I can't divide the first term by 5, so I can't divide any of them by 5 then. So I can't factor out a 5. But what I do see in all three terms is I see all of them have some x's in them. So I need to see how many x's I can pull out of everything. All right, so for that, you'll notice in the first term, there's 9 x's. In the second term, I have 4 x's. And then the last term, I have 3 x's. Notice the fewest number of x's that I have is these 3. That means I can pull 3 x's out of every single term. So I'm going to write an x cubed first. And then let's see why we can do that by actually taking a look at what that gives us. So that x to the 9th, if I take 3 of those x's out, dividing x's is like subtracting their exponents. So it leaves me with x to the 6th power. There we go. So x to the 6th for that first one. Minus. The 5 was unchanged here. Now if I have x to the 4th and I take away, I divide by x cubed, that leaves me with just 1 x left behind. So that's x or x to the power of 1, but of course we don't have to write the power of 1, right? Plus, now I have 10x cubed divided by x cubed. That leaves me just with 10. Notice there's no x's left because I took out, I divided by all 3 of those x's. And that's also what tells me I did it right. Because you'll notice that as I look inside here now, I have x's in 2 of the terms, but not in all of them. If there was still an x here, that would mean I could still factor out more x's. So it's a way to also check and make sure that you actually got all of them out. All right, and then for this one, the last one there, notice the 20, the 11, and the 25. I can't divide all of those by the same thing. And so I can't divide all the numbers by the same thing. So then I'm going to divide all the x's. And I can pull 6 of them out, yes. And so I'm now going to pull out x to the 6th. And if I do that, in my first term, notice the 20 is unaffected because the 20 is a number, it's not x's. And then x to the 8th, well, if I take 8 x's and I divide out 6 of them, that leaves me with x squared. And then plus, the 11 is unaffected. X to the 7th divided by x to the 6th is just x. And then minus, the 25 stays the same, and x to the 6th divided by x to the 6th, yeah, all the x's get canceled out there. And so then that is our final factored form for that one. All right, so now we're doing expanding again, but this time it includes both the numbers and the x's. And if we can get our head around this expansion with both the numbers and the x's all in there, then doing the factoring with numbers and x's, it'll be no problem because it's going to be the same idea. So I'm again distributing. So that means I do the 4x cubed times the x to the 7th. Well, notice the 4, there's nothing to change the 4, so it's going to stay a 4 there. Then I do x cubed times x to the 7th. When I multiply the x's, what do I do with their exponents? We add them. And so the x's become x to the 10th. Okay, next up, the minus stays a minus, and I multiply the 4x cubed by the negative 9x. So notice 4 times the 9 is the first thing we do here, which is going to be 36. And then the x cubed times x is x to the 4th, yes. Because remember, this x up here is x to the 1. Then minus 8x cubed. the biggest part of this one is making sure you understand why this particular one, that middle term, gave us what we did. Because notice I multiplied the numbers together, and then I multiplied the x's. And multiplying x's means adding their exponents. That's going to help you when we do our factoring here in a moment. All right, now we do the same thing with that last one. So the 10 times the 4 gives me 40. X to the 7th times x to the 5th. I add the exponents to get x to the 12th. Plus 10 times 13 is 130. That's going to be x to the 10th. Plus 1 times 10x to the 7th. Now notice, I can end it with just a 1 being there. That's useful information from later because we're going to do some factoring and sometimes people are going to forget that. But I had to have that 1 there in order to have something to multiply to get this. Because if I'm going to now factor with this sort of thing, that means I'd be going backwards, right? Because that's all that factoring is, it's expanding backwards. I'd have to look at every single one of these terms and say, what can I divide them all by? And so when doing that process, notice I'd look first at the numbers, 40, 130, and 10, and I'd say, what can I divide all those by? And you notice I can divide them all by 10. And the x's, I'd then look to see how many x's can I pull out of every term. And you'll notice that the fewest number of x's in any given term is 7, and so I can pull x to the 7th out of every term. That's the thought process we're going to use when factoring these. And so now we're actually going to go through that process of factoring them. Go ahead and write down these two problems, and we're going to go through that part. All right, so to factor that first one, basically there's two phases to it. The first thing I do is I look at the numbers. And so if I look at the 3, the 12, and the 30, what can I divide all three of those by? 3. And so that tells me I'm going to pull a 3 out of this whole thing. Then I need to look at the x's, see if I can pull x's out of every term. And notice there is at least one x in every term, so yes, I can pull out some x's. The question is how many? 3 of them, yes. Because of this being the smallest number of x's in a given term, that x cubed there. So it's going to be 3x cubed that we pull out of this. All right, so now let's go ahead and do that. For that first term, 3x to the 6th divided by 3x cubed. Well, the 3 divided by 3 gives me 1, and x to the 6th divided by x cubed. Remember, when dividing x's, it's like I'm taking 6 x's, this is x to the 6th, dividing it by x cubed, and you'll notice that when I divide those, 3 of them cancel out, and so I'm left with 3 behind. That's why it's an x cubed left. That's why we subtract the exponents there. Yep, and some of you might have written that 1 in front for the 3 divided by 3 equaling 1. That's fine, but remember that 1x cubed is the same as just x cubed, so we can make it a little bit neater if we do that. All right, next one. I have 12x to the 4th. First up, I do the 12 divided by the 3. 12 divided by 3 is 4. Then I do the x to the 4th divided by x cubed. X to the 4th divided by x cubed, it's like I got 4 of them, and I'm taking 3 of them out. And so that leaves me with just 1 of them. And so it's just a 4x then. Minus 30 divided by 3 is 10. X cubed divided by x cubed is 1. There's no x's left there. And so then we're done. For the second one, same basic idea. We start by looking at each of the numbers. 4, 28, 8. What can I divide all those by? 4, absolutely. So I'm going to factor a 4 out. Can I factor any x's out? Yes. Well, I do see an x in every term, so yes. How many can I factor out? 2, yes, because this smallest one here is a 2. So that's as many as I can pull out. So I pull out 4x squared then. And then I just go through and I divide all 3 of those terms by 4x squared. All right, so when we do that, for that first term, 4 divided by 4 is 1, so that goes away. X to the 9th divided by x squared is x to the 7th. Okay, then the minus stays a minus. 28 divided by 4 is 7. And then x cubed divided by x squared is just x. Then the plus stays a plus. 8 divided by 4 is 2. X squared divided by x squared, they fully cancel. So that is your final factored form there.